27 is one that we didn't talk about yesterday, and it's one where we have horizontal strips. Notice this time it tells us f of y equals y squared plus 1. It's not f of x. Sometimes you can change it to f of x fairly simply and integrate it with vertical strips, but sometimes it's going to be easier to integrate with horizontal strips. That means your equation's going to be in y, your integrand's going to be in y if you're using horizontal strips, and your limits are y values, not x values. So this is a good example. F of y is y squared plus 1. G of y equals 0. Y equals negative 1. And y equals 2. All right. If we change that function to x equals y squared plus 1, the only reason I'm doing this is to help me graph it. Because you may not remember from last year when we did conics what this looks like. But so this is going to be x minus 1 equals y squared. So y equals plus or minus the square root of x minus 1. This is going to be a sideways parabola. All right, so if we graph that sideways parabola, where is this function? This function y equals plus or minus the square root of x minus 1. Where is that equal to 0? At 1. Okay, do you suppose this is going to open to the right or to the left?
Right. To the right.
To the right. So the upper half looks like this, and the lower half looks like this. Okay, and then we're looking at, did I say, that should be g of y equals 1. Okay, so in other words, g of y is the same as x. Where is x equal to 0?
Y-axis.
The y-axis. There's my second function. And we want to find the area from negative y equals negative 1 to y equals 2. So say this is negative 1 and this is 2.
So it's all limited.
So the area that we're looking at, no, not drawn to scale. This is not on a coordinate plane, so it's not drawn to scale. But this is the area between here to there. That's the area we want. Now, I think that would be kind of hard to figure out all the x's if we're going vertical strips. But if we do, say, horizontal strips from here to here, do a Riemann sum like that, we're going to be integrating from negative 1 to 2. Those are my y values. And if I'm doing horizontal strips, my function has to be in y, which means I'm going to use that f of y, not my y equals. All right. This time it's going to be, instead of upper minus lower, it's right minus left. So which function's to the right?
F of y.
F of y. So it's going to be f of y, y squared plus 1 minus the left function, which is just 0. And that's dy. I didn't realize this one was in there yesterday when I assigned it. But we just ran out of time. We didn't really have time to get to the horizontal strip. So now we just integrate this just like we would if it was in x. It's just our variables in y. My limits are in y. So it's just like it was before. So when we integrate this, we're going to get 1/3 y cubed plus y. And we integrate from negative 1 to 2. So we'll have 8/3 plus 2, which is 6/3.
Wait, 8/3. Should it be 4/3?
It's cubed.
Cube over square.
Minus negative 1/3 minus 3/3. So we get 8/3 plus 6/3, which is 14/3, plus 4/3 is 18/3, which is 6.
That doesn't show up too good, does it?
No.
Y'all should have told me to change the color.
It does on the computer.
Yeah, I mean, here I see it real good, but it doesn't translate well. Okay, so does that make that a little easier?
Yes.
Other questions on your homework? Okay, number 9. Was all you had to do was graph that one?
Right.
We're going from 0 to 6. And you have 4 times 2 negative x to the 3rd minus x to the 6th dx. All right, so what's our variable of integration? X. All right, x to the 6th. How do we graph that? That's my y2.
You mean x over 6?
Mm-hmm.
So that, it just goes.
The slope is 1/6.
1/6,
So it looks something like that, except
Yeah.
it's straighter.
yeah.
All right. And 4 times, we'll worry about the 4 in a minute, 2 to the negative 1/3 x. There,
It's down.
it's going to be down, and if x is 0, it's 4. 1, 2. So it's going to be something like this.
Okay, so I got that. Mine just.
All right, so if we have, yes, it's curved. Now this is my upper function, this is my lower function. They probably intersect here at 6. It should probably be further over. All right, if we're integrating from here to here, so let's just say, let's see if I can erase that. They probably intersect right there. Okay, if we're looking at the area between 0 and 6, then this is the area. That would be the graph.
Oh, I colored in the wrong.
You colored in the wrong area.